Have you ever wondered how the intricate metal parts in your phone are made? Or how massive steel beams for a skyscraper are joined together? The world around us is built, piece by piece, through incredible engineering and manufacturing processes. From the tiniest microchip to the largest aircraft, it all comes down to shaping and joining materials with precision and ingenuity. Welcome to the Mechanist, your home for all things engineering. In this video, we're going to take a whirlwind tour of the fundamental manufacturing processes that make our modern world possible. If you enjoy content like this, make sure to hit that like button and subscribe to the channel so you don't miss our future deep dives. Now, let's get started. Let's begin with machining, one of the most fundamental and precise manufacturing processes used in modern industry. Machining refers to any process that removes material from a workpiece to shape it into a desired geometry, usually using tools that cut, drill, grind, or shave. The goal is high accuracy and a fine surface finish. One of the most common methods is turning. This is typically done on a lathe, where the part spins at high speed while a cutting tool removes material. Turning is ideal for creating cylindrical shapes, like axles, shafts, and bushings. Then there's milling, where the opposite happens, the cutting tool rotates, and the workpiece remains stationary or moves slowly on a table. Milling is perfect for flat surfaces, slots, pockets, and complex contours. It's widely used in mold making and aerospace parts. Drilling is another key method, used to create round holes. It might sound simple, but precision drilling is essential for mechanical assemblies, engine blocks, and circuit boards. Other advanced techniques include grinding, for high-precision finishing, and EDM, or electrical discharge machining, which removes material using electrical sparks. EDM is used when materials are too hard or complex to machine traditionally. Thanks to modern CNC machines, all of these processes can be automated, achieving extreme precision, repeatability, and even making parts overnight. Whether you're building a turbine blade or a smartphone mold, machining is where precision begins. Now, what if you need to join two pieces of metal together? That's where welding comes in. Welding is a fabrication process that uses high heat to melt the parts at the joint, and generally a filler material is added to form a strong bond as it cools. The result? A strong, continuous joint, stronger than bolts or rivets in many cases. Let's start with MIG welding, or metal inert gas welding. It's one of the most common types in industrial use. In this process, a wire electrode is continuously fed through the welding gun, while a shielding gas, like argon or CO2, protects the weld from contamination. MIG is fast, efficient, and relatively easy to learn, making it ideal for automotive and structural work. Then there's TIG welding, tungsten inert gas. TIG requires more skill, but it produces cleaner, more precise welds, especially in thin metals or stainless steel. It's the go-to method in aerospace and high-spec manufacturing. Another classic is stick welding, or SMAW. This method uses a consumable electrode coated in flux. It's great for outdoor work, pipelines, and repairs, since it doesn't need external gas and works well even in windy conditions. Welding isn't just a skill, it's an art, combining metallurgy, heat control, and precision. And with modern robotic welders, industries can produce thousands of perfect welds per hour with consistent quality. But what if you want to shape metal without removing any material? That's the principle behind forming. Forming processes use force to deform a piece of metal into the desired shape. This can be done hot or cold. First, we have forging, one of the oldest known manufacturing methods. It involves deforming metal using compressive force, usually with a hammer or a press. Traditionally done by blacksmiths, forging today is fully industrialized, used to make ultra-strong parts like crankshafts, gears, and connecting rods. Next is rolling, where a metal slab passes through pairs of rotating rolls that compress and stretch it into thin sheets. Think of how aluminum foil or steel beams are made. Rolling is essential in the metalworking industry for producing raw material stock. Another widely used process is extrusion. In this method, a metal or polymer is forced through a die to create a long, continuous shape with a fixed cross-section, like window frames, tubes, or plastic profiles. This is similar to squeezing toothpaste, but with industrial power. Bending is exactly what it sounds like, bending sheet metal into angles and curves to create enclosures, brackets, and all sorts of complex shapes. And stamping uses a die to press a sheet of metal into a specific form, often at high speed. Think about how car bodies are made, that's a lot of stamping. Forming is highly material efficient, meaning there's very little waste. It's also great for creating strong parts, since there are no weak points caused by cutting. And thanks to automated presses and rolling lines, forming is used in everything from car manufacturing to skyscraper construction. Now let's move to something more futuristic. Let's talk about the new kid on the block, additive manufacturing, more commonly known as 3D printing. Unlike machining, which is subtractive, 3D printing is an additive process. It builds objects layer by layer from a digital design. The most popular form is FDM, or fused deposition modeling. This process melts plastic filament, like PLA or ABS, and deposits it through a heated nozzle in thin layers. It's affordable, fast, and widely used for prototyping, DIY projects, and even custom tools. For greater detail and surface finish, there's SLA, or stereolithography. SLA uses UV light to cure a liquid resin, solidifying it layer by layer with incredible precision. This is often used in dental work, jewelry, and miniature models. But did you know that 3D printing isn't just for plastic? With SLM and DMLS, we can now print metal parts using powdered alloys and high-power lasers. This allows engineers to create lightweight, complex geometries that were impossible to machine before, ideal for aerospace, medical implants, and motorsports. The real power of 3D printing lies in its ability to design freely, produce parts on demand, and even localize manufacturing, cutting costs, lead time, and waste. From hobbyists printing figurines to NASA printing rocket parts in orbit, additive manufacturing is reshaping how we think about production, one layer at a time. So far, we've explored the most prominent processes in modern manufacturing, but there are still a few important ones you should know. First up is casting, one of the oldest manufacturing methods in history. In casting, molten metal is poured into a mold cavity shaped like the final product. Once it cools and solidifies, the mold is broken, and the part is ready. It's perfect for creating complex shapes in large volumes, like engine blocks, wheels, and even statues. Then we have injection molding, the king of plastic manufacturing. In this process, melted plastic is injected at high pressure into a steel mold. Once cooled, the mold opens, and the part is ejected. It's fast, accurate, and cost-effective for mass production, from bottle caps to smartphone cases. For cutting operations, laser cutting uses a focus beam to precisely slice through materials like metal, wood, or acrylic. It's clean, fast, and perfect for sheet metal work. And waterjet cutting, using high-pressure water mixed with abrasive, can cut through almost anything, including stone, titanium, and glass, with zero heat distortion. These processes may not always get the spotlight, but they're essential to modern life, from your car's rims to the chair you're sitting on. From ancient forging to futuristic 3D printing, the world of manufacturing is full of innovation, precision, and creativity. Every object around you, from your phone case to the bridge you drive across, was shaped by one or more of these processes. Whether you're an engineer, a student, or just curious about how things are made, understanding these techniques opens up a whole new way to look at the world. So, which manufacturing process fascinated you the most? Let us know in the comments, we'd love to hear from you. And hey, if you learned something today, don't forget to like this video, subscribe to The Mechanist, and share it with someone who loves engineering as much as you do. Thanks for watching, and see you in the next one.